There are several types of inclined planes: inclined airplanes, inclined planes, and inclined plane bagels, not to be confused with flat everything bagels. We're focused on the inclined planes that help you do work. Moving this person to, say, a height of 0.25 meters is easily done by pushing her up an inclined plane. Taking her straight off the ground, well, not so much. Here's why. Say you have George, the skateboarding giraffe, who needs to get on a 2-meter high stage via inclined plane with a 30-degree angle to the ground. Here you've got your normal force, the force perpendicular to the surface, and since he's not moving in that direction, we can say it's equal to the force going into the plane as well. We also have George's force of weight, simply his mass, 800 kilograms, times gravity, 9.8 meters per second squared. Then comes the force going down the plane, or the force with the plane, aka the whoop. And now by moving these vectors around, we get this nice little right triangle. The angle of the ramp is 30 degrees. That's also the top angle of our triangle. Since it after all is a right triangle, we can use SOHCAHTOA to figure out the normal force and the whoop because we already know the angle or hypotenuse. For the whoop, we get sine 30 equals opposite over hypotenuse. Do some plugging in into some algebra, and we get 3,920 newtons. The same method is used to get the normal force. Cosine 30 equals adjacent over hypotenuse, and now plug and chug, and we get a force of 6,789.64 newtons. Since George and his skateboard only encounter a wee bit of friction, we won't worry about the force of friction. So now we see all the forces involved with the inclined plane. What does this all mean? It means to get George moving, you must initially apply a force greater than 3,920 newtons. Now let's compare to how much force it takes to lift George up 2 meters. Since his force of weight is 7,840 newtons, your initial applied force would have to be greater than 7,840 newtons. Now let's compare. Without the inclined plane, you need 7,840 newtons, but with the inclined plane, you only need 3,920 newtons. But wait, you say, how do you know both situations are getting the job done? Well, let's see. We have the formula work equals force times distance. So without the inclined plane, we have work equals 7,840 newtons times 2 meters, which gives us 15,680 joules of work. Using the inclined plane gives us work equals 3,920 newtons times the 4 meters, which we use the right triangle trig to find. This also yields 15,680 joules of work. You do the same amount of work both ways, but the inclined plane allows you to exert a smaller force over a greater distance compared to exerting a larger force over a smaller distance, and, well, you saw what happened to the person trying to lift George. May he rest in peace. And the moral of the story, inclined planes for the win.
Use an inclined plane.
Inclined plane for the win.